Okay, number 6, you can win 100 bucks if you break a balloon, and you cost $5 to play, and you're willing to spend $20 trying to win. And you estimate your chances of hitting the balloon are 1 out of 10. I don't know where all these numbers come from, but anyway. So the random variable is $1. Okay. Now here's the individual probabilities. The individual events. You can spend $5 and get $100 for breaking the balloon on the first throw. That's $95. And your chances of that happening are 1 out of 10. So the probability that the random variable is going to equal this event, that the random variable x, namely $1, equals this particular event, x, is 1 out of 10. Now, before I continue, there's one thing that's really important to point out, and that these probabilities are disjoint. That means they have no overlap. That is, you either win it on the first throw, or you win it on the second throw, or you win it on the third throw, or you win it on the fourth throw. You don't win it on the first throw and the fourth, or first or the second, or anything like that. You only win once. As soon as you win, you're going to stop playing. Okay? And so we're talking about 4 disjoint probabilities and 4 disjoint events, and their probabilities are going to add up to 1. So you're going to win 95, you're not going to win 90, you're not going to win 100, you're not going to win 96, you're not going to win 94. You're going to win 95 because you spent $5 and you broke the balloon on the first throw, and the probability of that happening was 1 out of 10. Now, the next probability is you win $90, which means you missed on the first throw and you made it on the second. Okay, now the probability, now you can just multiply these two probabilities because the 2 throws, each time you throw the dart, it's independent of the previous throw. So we're going to say that the probability that you miss is 9 out of 10. The probability that you hit is 1 out of 10. Every time you throw the dart. Okay, so if you miss, which is probability is 9 out of 10 on the first throw, and then break the balloon on the second throw, which probability is 1 out of 10, the probability of that happening is 9 out of 10 times 1 out of 10, and you win $90. Now, if you miss the first 2 times, you miss on the first throw, probability 9 out of 10. Miss on the second throw, probability 9 out of 10. And hit it on the third throw, probability 1 out of 10. You will have spent $15, and you will have won $85. To go on. If you miss on the first throw, miss on the second throw, miss on the third throw, that's 0.9 times 0.9 times 0.9, or 0.9 cubed, but you hit it on the fourth throw, you will have spent your $20, which was your spending limit, and you will have won $100, spent $20, and so your net is $80. Now finally, you can miss on the first throw, miss on the second, miss on the third, and miss on the fourth. It's 9 out of 10 times 9 out of 10 times 9 out of 10 times 9 out of 10, or 9 out of 9 tenths to the fourth, and your net is negative 20. You spent $20 and won nothing. Okay, so this is the probability distribution for the carnival. So here's the probability model right here. So this is A. Now, B, find the expected number of darts that you're going to throw. Well, let's use the calculator to do that, because it also wants us to find, and the expected number of darts. All right. So let's throw this. I forgot to have the expected number of darts in here. Let's throw that in. Let's add this into the table. You throw 1, 2, 3, 4, and the expected number of darts here is also 4. Okay, 1, 2, 3, 4. You either throw 4 darts and you either win $80, or you throw 4 darts and you lose $20. Okay, so again, though, we'll use the calculator to do it. I want you to get used to it. You can do it by hand. If we did it by hand, the expected number of darts, let's write it out by hand. B. So the expected number of darts thrown, use D for standing for that random variable, is going to be 1 times 1/10 plus 2 times 9/10 times 1/10, 9 over 100, plus 81, 9 times 9 times 1, 81 over 1,000 times 3, plus 4 times 9/10 cubed times 1/10, plus, I got to wrap around to the other side here, 4 times 9/10 to the fourth. Okay, now this isn't that hard to do on the calculator. Let me clear this. Okay, so 1 times 1/10 is simply 0.1, plus 2 times 9 over 100, 18 over 100. Okay, plus 3 times 81 over 1,000. Well, 3 times 81 is 243. So that's 243 over 1,000. Plus 4 times, this I can't do in my head, 9 divided by 10 to the fourth, times 1/10, or 0.1. All right, let's double check. 1 times 1/10, that's 0.1, plus 2 times 9 over 100, 18 over 100, plus 81 over 1,000 times 3, okay, well, that'll be 243 over 1,000, plus 4 times 9/10 to the fourth times 0.1, plus, oh here, look what I left out, plus 4 times 9/10 to the fourth. Alright, I hit enter, and I'm going to get 3.409. So let's call it the expected, which is approximately equal to 3.41. Okay, now I'm going to check that real quick, make sure I didn't goof it up. Okay, 6A. Well, in the book they got 3.44. I wonder if I put in a wrong number somewhere. 0.09, 0.85, 9/10 to the fourth, 9/10 cubed 1/10, 9/10 squared times 1/10, 9. 0.44. Not sure why it's different, but anyway, I'll have to go with this for now. This is close enough. All right. Oh, here's my mistake. Right here, I can see it. I have 4 times 9/10 to the fourth. This should be 9/10 to the third. That's where I got off. Okay. Times 0.1. Okay. Now I've got 3.439. That's the right answer. The only way I could check it was by looking at the answer book. If you made that mistake, I wouldn't count that as a mistake. It's close enough. All right, but I did make a mathematical error nevertheless. All right, so that's the expected number of darts thrown. What's the expected number of money? Well, we're going to use the same process. It's going to equal 95 times 0.1 plus 90 times 9 over 100 plus 85 times 81 over 1,000 plus 80 times 9/10 cubed times 1/10 plus -20 times 9/10 to the fourth. Okay. So 95 times 0.1 plus 90 times 9 over 100, or 0.09 if you wanted to do that, plus 85 times 81 over 1,000 plus 80 times 9/10 cubed times 1/10 or 0.1 minus 20 times 9/10 to the fourth. Okay, 95 times 0.1 plus 90 times 0.9 over 100 plus 85 times 81 over 1,000 plus 80 times 9/10 cubed times 0.1 minus 20 times 9/10 to the fourth. All right, let's hit enter. And the expected winnings are $17.20, or 0.195. We'll call it 20 cents. It's approximately equal to $17.20. All right. Okay, and that's it. That's A, B, and then this was C. All right, so that was number 6. And now number 24, kittens. Don't we love our kittens? Except unless you're allergic to them like I am. Well, drop them all in a bucket of water. Okay, litter of 7 kittens. Okay, 7 kittens. Okay, 3 female. And, okay, so then 4 are male. Now, these are disjoint. That is, they are not independent and they have no overlap. Now, one of the things you want to be aware of, if probabilities are disjoint, they have no overlap. If they're not disjoint, then they do have overlap. Okay? Now, if probabilities are not disjoint, then you can model them with a Venn diagram or with a table and develop your probabilities in that manner. If they're disjoint, the thing you want to use is a tree diagram to develop your probabilities. Okay? Like, you test a drug, you're either a drinker or you're not a drinker, you pass the drug test or you don't pass the drug test, you're a liar or a truth teller. These are all disjoint categories, even though they're really not, but we're treating them as if they are. All right, so you want to know in 26, let's see, 24, I'm sorry, this is 24. Okay, find the probability for model for the number of males. Okay, so we're going to develop a tree diagram for this. Okay, because you are picking two kittens at random. All right, so we have male and female. Now the probability that the first kitten each branch, the first set of branches is choice 1, and then the second set of branches is choice 2. Okay, now we're picking without replacing. The probability of getting a male on the first pick is 4/7. The probability of getting a female on the first pick is 3/7. Okay, now the probability all right, now this is on pick 1. Okay, now the probability that given you got a male, you get a female, is going to be 3 out of 6. And the probability you got a male, given that you got a male, is going to be the same, 3/6. Why? Because you took a male out of the bag. All right, that leaves 6 kittens in the bag. There's now 3 females and 3 males. So the probability you get a female or a male on the second pick, given that you got a male on the first pick, is going to be the same, 3/6 or 3/6. That's because there's 3 females and 3 males left in the bag. We're still talking about disjoint probabilities as far as each pick goes. You're picking from a disjoint probability. However, the 2 picks themselves are independent, as we'll see in a minute, of each other. Okay, 1 pick is independent of the other one. Okay, the probability that you get a female, given that you picked a female the first time, is going to be 2 out of 6. Because you picked one of the 3 females on the first pick. There's now only 7 kittens in the bag. There's only 2 females that you can pick from. The probability you get a male, given that the first pick was a female, is going to be 4 out of 6. Now let's look at these 2 sets of branches. This probability is 3 out of 6. This one's 3 out of 6. They add up to 1. This one's 2 out of 6. This is 4 out of 6. They add up to 1. Okay, these 2 probabilities, 4/7 plus 3/7, add up to 1. Now, what's the probability that you get a male and a female? That's going to be 4/7 times 3/6. Okay, along this branch here. In other words, the probability of a male times the probability that you get a female given you got a male. We're using the general multiplication rule. Okay, the probability of a male and a male will be the probability that you got a male, 4/7, times the probability that you got a male given you got a male. In other words, you're coming off the male branch here. Okay, so that's going to be 4/7 times 3/6. And the probability that you got a female and a female is going to be the probability you got a female on the first pick times the probability you got a female on the second pick, given that you got one on the first pick. So that's going to equal 3/7 times 2/6. And finally, the probability that you get a female and a male is going to be the probability you got a female times the probability you got a male given you got a female, which is 3/7 times 4/6. Now these four probabilities should add up to 1. What do I have here? 8/6. That looks like 8/6. It's 3/6. That's crazy. Now, let's see if we can just add these up mentally. Okay. The denominator is 42 for each one of these. So we got 12 plus 12 is 24, plus 6 is 30, plus 12 is 42. So these four probabilities add up to 42 over 42. We don't have to use the calculator to figure it out. Okay, so now we have all of our so now we have a probability distribution that we're going to use to answer these questions. Okay, so a probability model, we're going to use this to make the probability model. Okay, so let me go back up here. So X equals number of males. Okay, so little x, you can get no males. You can get 1 or you can get 2. Right? And that's it. Now what's the probability that the actual number of males, so the random variable number of males, equals each particular event? Well, the probability of 0 males, in other words, 2 females, is 6 over 42. The probability of 1 male, that's going to be the probability of female and male and female. That's 12 over 42 plus 12 over 42, 24 over 42. And the probability of 2 males, a male and a male, is 12 over 42. And these add up to 1. 6 over 42 plus 24 over 42, which is 30, plus 12 over 42 is 42 over 42. So here's our probability model right here. Okay? Okay, now, so that's A. We've answered A. Let's do B. For the kittens, what's the expected number of males? All right, it's going to the expected number of x, where x equals the number of males, is going to equal 0 times 6 over 42 plus 1 times 24 over 42 plus 2 times 12 over 42. Okay. Now, we got 6 over 42 plus, oh, that's a 0. Hold on. That's 0 times 6 over, so forget that. 1 times 24, so we got 24 over 42. So nice if I remember how to write. 24 over 42 plus 24 over 42, which is 48 over 42, which I believe is 1 plus 6 over 42, which is 1/7. And then 1/7 is 142,857, repeating. Okay, so the answer for B, let me check this. With the kittens, I gotta get out the old, make sure I'm not screwing up. I should have checked it before. Okay, 20, except I did this before. All right, so yeah, 1.14 number of males, and here's our probability distribution, looks fine. Okay, C, what's the standard deviation? All right, well, this is going to be a real pain in the neck to calculate, especially with a repeating a repeating decimal as part of my expected value. Anyway, the standard deviation, just to remind you, the standard deviation of a random variable x equals the sum of each individual x minus the expected value of x squared times the probability of that particular x. Okay, and put the last parenthesis. Anyway, that's it. This is a lot harder to calculate than the expected value. So now we're going to do this. We're going to use the calculator. So we're going to do stat and edit. And I got all this other stuff in here, which I'm going to get rid of. And then go over here to L1, clear, and enter. Okay, so in L1 output is going to go with the possible number of kittens, the x's. Okay, we can have 0 kittens, we can have 1, or we can have 2. Okay, now the probability of 0 kittens is 6 divided by 42. And the probability of 1 kitten, 24 divided by 42. And the probability of 2 kittens, 12 divided by 42. Okay. Those look like they probably add up to 1. Let's double check. 6 over 42, 24 over 42, 12 over 40. I wish you would just continue to show the fractions. That would really sort of be nice. Okay, stat, calc, one variable stats, and we got to do it on L1 and L2 since we're using L2 as effectively as the quantitative. It's a quantity. Okay, we see n equals 1. That's good. Now we can see that the mean 142,857. See, there it is, the repeating decimal. So we nailed the mean, and the standard deviation is 0.638, approximately equal to 0.639. Let's call it that. Okay, and let's see how finicky the book is for the standard deviation. Oh, they just call it 0.64. Okay. Anyway, so the standard deviation, in other words, the standard deviation for the expected number of males is 0.64. Okay, on to 26. All right, random variables. Now, they're telling you that x and y are independent, and so find the mean and standard deviation of, okay, so A, x minus 20. Now, the mean for x, here, let's put them up here, okay, got our little table, let's just write it on here, mean, standard deviation, and over here, we got x, random variable y, 80, with the standard deviation of 12 for x, and y is 12 and 3. Okay, so x minus 20 is going to be mu equals 60, standard deviation equals 12, because the standard deviation is not affected by changes by addition or subtraction, just like it, just like before. B, 0.5 y. Okay, the mean equals 0.5 times 12, 6. Sigma equals 0.5 times 3. Remember, the standard deviation is affected by multiplication. That's 1.5. Okay, C, x plus y. Okay, mean equals 80 plus 12. That's 12, which is 92. sigma equals the square root of the variances, of the sum of the variances. The standard deviation is 12, so the variance is 12 squared for x, and the variance for y is 3 squared. So it's the square root of 12 squared plus 3 squared, which is 12.37 about. Let's see how that looks. I'm going to check these answers as I'm going along here so I'm not making a mistake. Everything looks good. D. X minus y. Mu equals 80 minus 12, which is 68. Sigma remains 12.37. Whether you're adding or subtracting two random variables, the standard deviation remains the square root of the sum of the variances. Does not change. Okay. Okay, y sub 1 plus y sub 2. In other words, two different instances of the random variable y, like I sold, like when we were talking about two insurance policies or whatever. Okay, mu equals 12 plus 12, which is 24. Okay, and sigma equals the square root of the sum of the variances. Okay, which is 3 squared plus, so that's 3 squared plus 3 squared, which is 18, right? 9 plus 9 is 18, so the square root of 18, which is 3 root 2, whatever. Okay, so the square root of 18, which is 4.24, approximately equal to 4.24, and I'll check that last one for 26. 4.24 and 24. Okay, so that's it. That's how you do them. That's the end of these three problems.